seaside in Aberdeenshire on the Balmoral estate. We are hiking to see some of the cairns. There are 16 cairns around this estate, which are stone monuments to monarchs and members of the royal family. In particular, we're going to see Prince Albert's cairn, which holds a special relationship to VT SCADA. More about that later. Try and keep up. So here we are at Prince Albert's cairn, and as you'll appreciate, it's quite unusual to have a pyramid in the middle of Scotland. It was erected by his widow, Queen Victoria, in 1862 in his memory after his death. It was this cairn that I wanted to discuss with you, and similarities to VT SCADA, and indeed the monarchy, which has a very defined hierarchy. So does VT SCADA, and it's very similar in many respects to a pyramid. At the bottom layer we have the VT SCADA engine. The VT SCADA engine is developed by Trihedral and written in C and C++. And in fact, it is a compiler and interpreter for our VT SCADA script language. The VT SCADA script language is fairly unique in that it is a reactive programming language that is state-based. It's for this reason the VT SCADA is so very scalable. It's able to monitor 1 or 2 I/O, and the same application can scale up to 1.5 to 2 million I/O. It is all based on reactiveness to I/O stimulus. So if there is no stimulus, so there is no data changing in the plant, or the operators aren't interacting with the system, then the system is effectively idle. Our worst case scenario comes when we have a data flood. So a flood of alarms where there's a lot of stimulus and a lot of I/O changing, and we're able to react to that stimulus. The next layer is the VT SCADA layer, and that contains all of the components that you'd be familiar with, such as the historical data viewer, the alarm manager, the page manager, all the widgets and all the drivers. Again, all of these components are developed by Trihedral in-house so that we have full control over the development process, the quality of these items. The top layer, in many cases, is an end user application. The end user application sits on top of VT SCADA and inherits everything from the layers below into that application. So you can use all of the pages and all of the widgets and all of the facilities that we have created in VT SCADA. The end users are able to add new tags and create new pages, add new widgets, and extend the capabilities of VT SCADA. However, we do have the ability to create an additional interposing layer above the VT SCADA layer, but below the end user application, which allows OEMs and system integrators to develop a suite of their own tools and custom components. That might be things such as custom pages, custom widgets, new drivers, new tags. Now the use case for this is where we have an OEM or a system integrator who has many customers, and they want to provide a standard set of tools that the end customers are able to use. The end user of these applications might be very different, and so they may have different color for open and close valve, or they may have different page styles or page layouts, which can be customized at the top layer. In the same way that Trihedral develops VT SCADA tools, the end user or system integrator can create their own tools. The end user application inherits all of these. When the system integrator makes new changes to their OEM layer, they can deploy that separately to the end user applications. So it's this reason that VT SCADA is like the Prince Albert cairn here in Balmoral in Scotland.